Hello, our last section for Unit 5 is using the quadratic formula in word problems, or in other words, quadratic applications, how these show up in problems in real life, because y'all always want to know, how these things fit into a real life situation. So let's look first at this problem. Now this is very much like we did at the end of the last unit. An archer shoots an arrow into the air. The equation that describes the path of the arrow is h equals 17t minus 5t seconds, where h is the height in meters and t is the time in seconds. All right, so how high is the arrow after 2 seconds? So what we're looking for here would be our h, and the 2 seconds is our t. So we're just going to use the formula that's given to us. H equals 17 times 2 minus 5 times 2 squared. Okay, 17 times 2 minus 5 times 4, okay, was going to be 34 minus 20, or H equals 14 meters. So finding the height when you know time in this type of problem is easy. It's a little harder to find time because there's two things that have the time variable in it. So when, that's your time, will the arrow be 10 meters high? That's your height. So H is 10 equals 17, and we're looking for our t, minus 5t squared. Okay. Using quadratic formula, I'm going to show you now. We haven't ever done this. I've always said make your t positive, because that way you can check to see if you can factor. But if you know you're going to use a quadratic formula, we could move this 10 over and have minus 5t squared plus 17t minus 10. I would still suggest that you put it in the order of biggest exponent down to no exponent on your variable. So A is negative 5, B is 17, and C is negative 10. So putting it in the quadratic, x equals negative 17 plus or minus the square root of b squared, that's going to be 25, 5 times 5, minus 4, b squared, Erase that, I had a squared, 17 squared, minus 4 times negative 5 times negative 10. Okay? So we end up with x equals the square root of negative 17 plus or minus the square root of 89 and when we go through, and all that's going to be over, I forgot to put this over, 2a, which is 10. So this is over 2 times 5. I just forgot to put it in here. All right, now, when I do our math, I have one of them, negative 17 plus square root of 89 is going to be 2.6 seconds, rounded to the nearest tenth, and the other one is going to be 0.8 when I do the subtraction problem, seconds. Okay. And again, it hits that at 0.8 seconds going up, and then at 2.6 seconds going down. When will it be 20 meters high? So you put 20 in here. 17 minus 5t squared. There's a t on the 17. Okay. Now this time I'm going to go ahead and move this over like I've always told you to. Make the positive 5t squared minus 17t plus 20 equals 0. I still think that's the easiest way to do it. All right, so A is 5, B is negative 17, C is 20. So x equals negative 17 plus or minus the square root of negative 17 squared minus 4 times 5 times 20. All of that over 2 times 5. Okay, so x equals 17 plus or minus the square root of negative 111, all of that over 10. Now, the answer, remember we can't have a negative under the radical and get a square root. Our answer was no real solution. So in that case, when we have this path that this arrow is going to follow as it goes up and then comes down, we're saying that this never hits that 20 feet. It doesn't ever get there. So, never is your answer on a word problem. When will it be 20 meters high? We can't solve it, so it must never be 20 meters high. Okay, when will it come back to the ground? When is time? What is our height? Again, this is the one people always miss. When it hits the ground, the height is 0. So we have a value for our height. So 0 equals 17t minus 5t squared. On this one, you don't have to use quadratic. We can just factor out a t, and that leaves me with 17 minus 5t. This t right here is the starting point. That's where time is going to equal 0. That's where the arrow starts. So then when we set this other factor equal to 0, we have 17 equals 5t, and so t is 17/5, or 3.4 seconds. Okay. So that's one of the application problems. This is one you've already had. We did that last time, so this is just another example. You've already had a couple on your homework. It's just hopefully reinforcing and helping you understand a little better, more practice on this type of, this is the type of problem you're going to run into a lot in school, especially as you get into physics. All right, on our next page, let's see, go back to our mouse and move down. Okay. The next page is just a single problem. The area of a rectangular piece of cardboard is represented by the equation W times 2W plus 3 equals 9, where W is the width of the cardboard. Find the width. Okay. Well, you might think, well, this is already factored. Just set them equal to 0, but it's equal to 9 here. So we can't do that. We're going to have to distribute the W. And so let me just write the problem as we have it, as it's given. Okay, so we're going to distribute this W first. And so we'll end up with 2W squared plus 3W minus 9 equals 0. Now this looks like a quadratic that we could solve. And, you know, we could check to see if you could factor it. But you're going to look for factors that will add to be negative, or multiply to be negative 18, and add to be positive 3. Well, there is a factor that will do that. It is 18. So you can use either method. We're going to use quadratic first, A, B, and C. We have negative 3, x equals, plus or minus the square root of 3 squared, which is 9, minus 4 times 2 times negative 9, all over 2 times 2, which is 4. So that's negative 3 plus or minus the square root of 9 plus 72 all over 4. Negative 3 plus or minus the square root of 81 over 4, and the square root of 81 is 9. So you end up with 6/4 when you add it, which is 3/2. Or negative 3 minus 9 is negative 12. So that's negative 3. Okay. And width can't be negative, so my answer is going to be 3/2. Now we could try to factor it. Again, we want factors that add to be, or multiply to be negative 18w squared, and add to be 3w. Now we have to have a plus and a minus. I wrote squared and I meant w. Okay. So that's going to be a plus 6w and negative 3w. So now we can factor by grouping or factor using the box, but I'm going to factor by grouping. You have 2w squared minus 3w plus 6w, and remember all that combines to give you your plus 3w right here, and then minus 9 equals 0. You group them. On the first set you can factor out a w, which leaves you 2w minus 3. On this one, you're going to factor out a 3, which leaves you 2w minus 3. And so our two factors are w plus 3 and 2w minus 3. And that equals 0. So the value for w when we solve these is negative 3. On this one, it's going to be positive 3/2. And again, same answers either way. And the positive 3/2 is the one we're going to choose because you can't measure a negative. Okay? And that's all there is for examples on 5.5.